Hey, what's up, you cyber sleuths? Today we're diving into Sherlock, not the detective, but the OSINT tool that can find anyone across 300 plus social platforms in seconds. OSINT stands for Open Source Intelligence, and it's all about finding information that's publicly available but scattered across the internet. The original Sherlock is a Python command line tool created for security researchers and, let's be honest, stalkers with too much time on their hands. But we're taking it to the next level by turning it into a full-stack web application with a React frontend and FastAPI backend. Let's break down how this digital detective works in under 10 minutes. The core of Sherlock is a Python FastAPI application that handles the heavy lifting of searching hundreds of sites simultaneously. We've got two main endpoints, one to start a search and one to fetch results. When a search is initiated, we spin up an asynchronous background task. This is crucial because searching hundreds of sites can take time. By using a background task, we keep the UI responsive while the search runs. The second endpoint is where the front end repeatedly checks for results as they come in. What's interesting here is our simple but effective approach to real-time updates. As the background task finds matches, it writes them to a text file. When it's done, it adds a special stop marker at the end. The real magic happens in the Sherlock main function, which utilizes multi-threading to check hundreds of sites simultaneously using futures. This custom futures session tracks how long each request takes, which is useful for benchmarking but also helps us detect rate limiting and other issues. Sherlock determines if a username exists on a site using different detection methods stored in a massive JSON configuration file with rules for each site. Front end is built with Next.js, giving us server-side rendering and a smooth, fast user experience. Let's start with the homepage, which is delightfully simple. Just a simple form that takes a username, sends it to our API, and then navigates to the results page. The real action happens on the search results page. Here's where our front end gets interesting. We're implementing a simple polling mechanism with set interval, checking for new results every 500 milliseconds. When the stop flag is true, we know the search is complete and stop polling. The UI automatically scrolls to show new results as they come in, creating that satisfying feeling of discovery as matches are found. We also have functions to download all the found URLs as a text file or open sites in a new tab. The results UI has a pulsing animation while the search is running, giving visual feedback that work is happening. Both our front end and back end are containerized with Docker, making deployment a breeze. The back end uses a slim Python image, while the front end uses Node.js with a multi-stage build to optimize the image size. And there you have it, a full-stack OSINT tool that can search hundreds of sites in parallel using modern web technologies. What's particularly elegant about this implementation is the simplicity. Instead of complex WebSockets or a database, we're using file I/O and polling. Sometimes the simplest solution is the best one. The app also has responsive design for mobile users, clean error handling, and even progressive web app support. Before you go build your own stalker tool, remember to use this responsibly. OSINT is a double-edged sword, great for finding old friends or checking your own digital footprint, but potentially invasive when misused. That's it for today. If you want to dive deeper into the code, check out the link in the description. Don't forget to hit like and subscribe for more tech breakdowns.